In this video, we're going to take a look at how to copy nested cabinet parts from CabinetPartsPro into Vectric product. It will work with either Vcarve Pro or Aspire. So we'll start off first by nesting one cabinet, and we're also going to take a look at how toolpath templating works within the Vectric products. So with only one sheet nested, we'll go to Edit, select CopyToVectric. We get a message that we are ready to paste into Vectric. Once that is done, we'll come down and I will start Vcarve Pro version 11, creating a new file, specifying the job size, X, Y, and Z being 3/4 inch material, 4x8 sheets. And since we're doing cabinets, and I'm not concerned with how deep each feature is into the material, it could be a few thousandths or even 10,000ths off in the depth and still be okay. I'm more concerned about how deep we'll be cutting into the spoil board. And it's easier to control the depth into the spoil board with having the Z zeroed to the machine bed. The reason for that is material thickness from one sheet of plywood to the next is not the same. So if we zero to the top of the material on a sheet of plywood that measures a little bit less than 3/4 of an inch, that means that when we tell our cutting to go to 0.3 or 0.75, that we're going to be cutting in deeper than we expect it to be. But now if we are zeroed to the table surface or the machine bed, when we tell it to cut down to a total depth of 0.76, we truly know that we are cutting only that 10,000ths into the spoil board. Selecting OK starts our new job. We have that data copied to the clipboard, so now it is just a right click and paste. And here is our job, nested out the same way we had in Part Nester and CabinetPartsPro. We are now ready to set up our toolpaths for this job. As it was brought in and imported, it was brought in on separate layers. We could see that each layer, or most of the layers, have data and some layers don't. We could see what layers have vectors associated with them on the little icon of this sheet. We could see that layer 1 and layer 0 do not have any data associated with them. Just to clean things up a little bit, I'm going to remove those layers by right-clicking, selecting delete and delete this, and doing the same thing for layer 0. The material layer is one that is providing the vectors that are representing the material, the 4x8 sheet. We don't need to have that data either. So I'm going to right click and delete this. This time we're going to get a warning, or asking, not necessarily a warning, but what do we want to do with the data that is on that layer? We could move it to a different layer, or we could choose to delete the data. I don't need to have that rectangle representing that material, so I'm going to choose to delete that data, and we'll say OK. The next step in the process to automating future nested or future jobs that have been imported, we're going to go through the process of creating a toolpath template. So I'm first starting with the layers and just confirming that each data is on the layer and understanding what each layer is. And I'm going to set the layers up in an order that I would want to have them cut. Not that that really makes any difference in the final end product or the end game of our toolpath template. It just makes setting it up a little bit easier, at least for me. Basically starting at the top of the list and working our way down. So we have the shelf holes, hinge holes, which are our shelf holes, and 2 hinge holes, the backside datas, which are the dado selecting here, and then we have the back dado, which is a rabbet that is on the back side of the cabinet. Then finally the cut, which is the perimeter cut or the final cutout of these components. So now that we have an understanding of what we're going to be doing, the first two toolpaths we'll use a drilling method for. And we're going to go over to the toolpath template. So normally you would want to switch from the drawing side to the toolpath side. In this case, I want to have the layer tab open as I'm creating these toolpaths, just so we could get a flow and an understanding of what we're processing. So coming over to the toolpaths tab, going to set the tick to lock it open. And starting right at the top of our layers list, we are going to set the toolpaths for the shelf holes. That's going to be a drilling operation, so we'll select the drilling toolpath. The cut depth, even though we have a value here, I'm not going to worry about that. I'm just going to enter in a value of 0 just so you can see how this is going to get updated. And also notice I came into this drilling toolpath without pre-selecting any of the vectors, and I'm not going to use the mouse to select any of these vectors. We're going to use the layers or the selector at the bottom of each toolpath operation. You have an option for this selector. Clicking the selector button opens up a form to allow us to be able to select all closed vectors and have them be selected based on a layer name. So notice that when I selected the shelf holes, all of the shelf holes have become selected. I want to also have associate with toolpaths checked. That is an important item to have checked for when we go to save this as a template. If that is not checked, any newly drawn items or that toolpath template just isn't going to work for us. We also have these vectors have been imported from an outside source. So we're able to use the depths that are associated within the imported vectors for a reference Z. So I'm going to delete this offset just so we can see what's happening here. The second, we're going to close this now, and we can see that the cut depth is a total of 1 1/4 inches. The total depth of these holes are really only 1/2 inch. But since we've set to 0 to the machine bed or the table surface, that thickness is also being applied to our cut depth. So to get around that, in the selector, this Z offset, we're going to enter in a -Z. The Z is a vector variable for the material thickness or the Z level of that. So entering in, subtracting out the Z value from the imported vectors should now give us a total cut depth of 1/2 inch. This next step in the process is selecting the bit. I'm going to use a 5mm bit for drilling, making sure that I have in the correct tool number if you have a tool changer, and we'll go ahead and select that cutter. Coming down to the bottom, I'm going to give it a name, and I want to give it a logical name for what it's representing. And for me, the best way to keep track of toolpath templates that are based on layers is give the toolpath name the same name that it is being associated with that layer. So I'm just going to come over to the layers list, right click, select rename, and do a copy of the text, and coming down here to the bottom and giving that a name, selecting calculate, and close. I'm going to follow the same steps for the hinge hole vectors or the layers for hinge holes, selecting to drill, using the selector to associate with that toolpath. It's an important one to remember. And again, I'm going to give it the same name, Control C, and then a Control V. So rename, Control C to copy, give it a Control V to paste, and clicking calculate. The next two are going to be a profile toolpath, and we're going to profile to the inside of the selected vectors. So going to a profile toolpath. Again, I'm not worried about the depth because we're going to set that using the selector. Again, associate toolpaths. And that Z is still set from the previous. We still need to subtract that, and we can see that that is being updated to a cut depth of 3/8 of an inch. Selecting the cutter, I'm going to choose to cut this out with a 3/8 diameter cutter. And coming down to the bottom and giving it a name. Again, it's just a copy and paste from the layer name to the toolpath name. And the great thing about the preview of what we see here is I see right away that I've made a mistake or forgot to do something. That looks like a very large diameter dado that's going to be produced. So you can zoom in here and you can see that it's being offset to the outside. That is not what we need. We need to have it offset to the inside. That's okay. We could correct that by just double-clicking the toolpath, coming in and correcting my mistake, and offsetting to the inside to the left, and come back down and select Calculate. We now see that is correct the way I would like to have that. The next next one is going to be created exactly the same way, offset to the inside. So I'm going to create a profile toolpath, come down to the selector, associate, uncheck the back side dados and check the back dados. And again, another copy and paste for the name. Now here's another situation that kind of happens here. I kind of expected to see a blue line coming across here for that dado, and we're only getting, looks like a little drilling there. So let's investigate what's going on there. Now just at the end, so if we just select just this rectangle, we could see that the total height of that, or the total width of that, is exactly the same as the bit diameter. And Vectric and Vcarve is saying, hey, this bit really doesn't fit. We could get around that. I'm going to get around it by giving it a offset allowance. So again, double clicking on the toolpath, giving it an offset allowance of 0.001, and selecting Calculate again. Now it's really saying, like, well, it doesn't fit. Well, it doesn't because we've asked it to subtract a thousandth of an inch, or really add. So we need to subtract out that 0.001 and come down and select Calculate. We now see that we have that dado has been applied. The final layer is the cut. And I am selecting as I'm coming down this layer list, not that I have to, but it's helping me keep track of what toolpaths I have not created as of yet. So when I created the backside dados, I could see that's where I was. Now I'm creating the toolpaths for the final perimeter cuts. That is going to be a profile toolpath to the outside. So I'm going to change this to the outside, and again, I'm not going to worry about selecting vectors or creating that depth, just using the selector to be associated on the cut and close. We now have the total cut depth to be 0.75. In a perfect world, that would be good, but we do need to cut a little bit deeper to make sure that we don't get any fraying, or perfect is not what we're needing. We need to go a little bit deeper to make sure, and to ensure that we do go all the way through our plywood. So again, I'm going to use the selector and the Z offset to adjust that. So I'm just going to enter in a plus 0.02, just adding 10 thousandths to that cut, or that total cut depth that has been brought in from the imported vectors. Closing there, and we could scroll back up to the top, and we see our total cut depth is now 0.77. I have a total pass depth here. I'm going to make a change and edit that to cut a total of just full depth. I don't want to make multiple passes. So the pass depth, any number that I enter in here that is greater than the material thickness is going to work. So by entering in 1 doesn't mean it's going to make one pass, and in this case it is. But I could enter in 0.15. That doesn't mean it's cutting to a depth of 1.5 inches. It just means that we are going to limit each pass to a depth of 1.5 inches or 1 inch. Scrolling down to the bottom and going to give that a name. Then calculate. Getting this warning, 0.75 is my material thickness and 0.77 is my total depth. That is acceptable to me. That's 20 thousandths. And saying OK. We now have completed all of the toolpaths necessary to cut this sheet out. I've previewed it. It looks good. I just want to double check each one of these again just to make sure that this says automatic. That automatic is based on the selector of being associating with the toolpaths. So we definitely want all of these to be set to automatic. For just cutting this one sheet out, it does not have to be set to automatic. The reason that we're making sure that it's automatic now is we are going to save these out as a template for when we bring new material in or new parts in, we're able to, it will automatically recognize the new vectors on that layer and also recalculate those automatically. I'm going to put a tick mark in to select and make all toolpaths visible. Going to use the option to save all visible toolpaths as a template. Just going to give it a name of cabinets. Clicking save. We could now close Vcarve Pro. We've done all the hard work, and it's going to be much easier for when we bring in a new job. And to demonstrate that, I'm going to also close out our nesting. And I'm going to add in a total of, instead of 1 cabinet, let's do 5 of this size. Selecting Calculate and Nest. We now have a total of 5 sheets. We could see that by scrolling across the top. Going to Edit, CopyToVectric, and it is ready to paste in. Opening up Vcarve Pro. Creating a new job. Selecting OK. Right-clicking, then paste. We now have the 5 sheets brought into Vcarve Pro. We could make double-clicking on any one of the sheets makes that sheet the active sheet. And we could make any kind of modifications or add vectors or do whatever we would like here. But if all we want to do is calculate the toolpaths for all of these parts, we will go over to the Toolpath window and select to load a toolpath template. There is the cabinet's toolpath template that we just created. Selecting Open. We are now being asked, do we want to apply this template across all of the nested sheets? We will say yes, that is exactly what we wanted to do. We're getting the warning that we are cutting through on that cut. That is just fine. That's what we want. We're going to get that for each of the nested sheets. And now in our toolpath list, it has grouped our toolpaths based on the layers, or based on the sheets and the template that we have selected. So under sheet 1, selecting the plus to make all of those toolpaths visible here, we could see that there. Let's take a look at sheet number 4, making that active, and we can see that there isn't any other feature on there other than the cut, the perimeter cuts, and that is the only toolpath that was created for that particular sheet. Now for saving these toolpaths out, we're going to use the option to view all sheets, putting a tick mark in there to select all of the vectors, coming to Save Toolpaths, and we want to use the option to save all visible toolpaths to one file or multiple files and group where possible. So what this is going to do is it is going to give us one toolpath for each nested sheet. Hopefully this was of some use for you. If you have any questions, please let me know.